Okay, today we are talking about assignment number 41, the Trig review worksheet that I posted. So whether you're doing this with Miss Sanchez in class, in person, or whether you're doing this on your virtual time, the worksheet here has been provided showing some background information on Trig, showing an example with all the steps on Trig. I'd like you to write that one example down just as a quick reminder for how to solve, set up the equation, etc. And then we're going to do examples 1 through 12. Why are we not doing 13, 14, 15, 16? If you notice, these ones are not missing a side, but they're missing an angle. That's using something called inverse trig, which we have not learned yet. So we're not doing 13 through 16. And then there's a couple application problems here at the end. Okay, so this worksheet needs you to have a Desmos calculator available so that you can calculate some trig. And so I'm going to go over here onto this Jamboard so that we can work through some of these problems. And so if you're watching, you can follow along with my video to take care of this work for today and then upload your notes when you're done. So the first example that was given to us as a notes example is not only having us solve for y, but h also. There's two variables here. So here we go. Let's go try first solving for the y. So if I'm looking at the reference angle here of 42, if 42 is my reference angle, I'm noticing that I'm solving for an opposite, and then I was given an adjacent. So I look down here at my trig functions, sine, cosine, and tangent, or my SOHCAHTOA, and I'm noticing that which one uses opposite and adjacent. This first one to solve for y is going to be a TOA, a tangent, because we're using the opposite and given the adjacent of 17. So let's solve the y first by using the tangent. So step 1, identify which trig function. Step 2, plug in to the trig function. Tangent of 42 degrees is equal to the opposite over the adjacent, and then step 3, solve. Multiplying by the 17 to both sides to get rid of that denominator. What we're actually going to plug in to the Desmos calculator right now is the tangent of 42 times 17. And this is going to give me an approximate value. Sorry, let me switch this to a y. So 17 times the tangent of 42 is going to give us 15.31. Do you see how I'm rounding here to 2 decimal places? 15.31. So in all of your time at El Camino doing math, you're going to always round to 2 decimal places unless you were told otherwise. Why is this approximate? Because we're rounding. This is going to have a units of feet, and this is an approximation symbol since we rounded. So are you okay with this answer? Do you see how we did everything there for that y? Now we're also going to solve for the h next. So this h is a hypotenuse. We're still using the reference angle of 42. So this time we're going to use this 17 as an adjacent leg to the 42, as well as the hypotenuse is what we're solving for. So using the adjacent and the hypotenuse, which trig function is that going to be? Adjacent and the hypotenuse is going to be our cosine, our CA. So here we go. Step 1, identify. It's going to be a cosine. Step 1 was identify. Step 2 is plug in. And so we're going to go cosine of our angle, 42 degrees, is equal to the adjacent over the missing hypotenuse h. The variable's in the denominator. This one's going to be a little bit different. This time we're going to multiply by that h to bring it upstairs. So we're going to get h times the cosine of 42 equals 17. And then there's additional step of dividing by the 42, cosine of 42. So this time when we plug it into Desmos, it's going to be plugging in 17 divided by the cosine of 42. And anytime we have a variable in the denominator that we're solving for, we know there's going to be a division happening. So 17 divided by, and how do I get to divided by? Do you see that button I just used? The cosine of 42. And we got 22.875, so we're going to round up to 22.88. Remember, we're going to round to 2 decimal places unless told otherwise. We're using the approximation symbol because of the rounded, and this is still feet. So for the first part up here, I solved for y. And then in the second part, I solved for the hypotenuse. This was our notes that we're doing in class today. In order to remind ourselves about trig, we're now going to go practice repetitive practice on trig to see how you're doing. Are you going to be able to start identifying those trig functions? Are you going to get better at it? Are you going to be good at solving them, etc., for this upcoming test?